Hi, this video is about solving problems with impulse and momentum. So imagine we have a situation like this. We have a 150 gram baseball and it's thrown at a speed of 20 meters per second. And it's batted straight back at the pitcher at 40 meters per second. If the bat is in contact with the ball for 0.60 milliseconds, it's a pretty short time, what's the average force the bat exerts on the ball? That's a typical kind of question that I might ask you about using impulse and momentum. First of all, I would point out that there are two figures, or the two numbers in this question that are not standard SI units. 150 grams, remember kilograms is the standard unit, and this milliseconds is also non-standard. So you might want to think about converting those ahead of time. 150 grams into kilograms, well, that's less than 1,000 grams, so what we have here is less than a kilogram. We just divide that by 1,000 and get 0.150 kilograms. And 0.60 milliseconds, remember milli is 10 to the minus 3. So that's 0.60 times 10 to the minus 3 seconds, or 0.00060 seconds. So it's a pretty short time. It's a little review for that. We're going to take a kind of a formulaic approach like we do with many of our questions in solving them. And this is the step here. There are 4 basic steps, well 5 I guess if you count the solution. So the first step in solving this problem is to sketch. We're going to make 2 drawings, a before picture and an after picture. And we're going to see that a lot here, this chapter with momentum, before and after. And so that's what I've done here. I drew the bat and the ball. It's going towards the bat. That's the before. And then afterwards the bat's angled, of course, forward, and the ball's going the other way. So that's the first step. Pretty simple thing. Second step is to establish a coordinate system. Remember, momentum and impulse are both vector quantities. So it's important to know if things are moving forward or backward, positive or negative, and so on. So I've drawn a blue line here with labeled it X. Let's let positive X be to the right and negative be to the left. Third step is to define symbols and list the known information on the drawing. I don't think that there's too much information that you can't just list it on the drawing. I don't think you need to list it twice. So if you define the symbols on the drawing and list the information there, that's probably good enough. So I've labeled the initial velocity VI, and I made it 20 meters per second, and I put a negative sign there because according to our coordinate system, negative is left and it's moving left. The mass I listed for the baseball is 0.15 kilograms. Remember, we converted that on the last board. The final velocity is positive 40 because it's moving to the right now. And then I also listed the time as this 0.6 milliseconds, or 0.00060 seconds. Fourth thing, identify the desired unknown, and what we want to know is how hard did that bat push on the ball, at least on average. It might not be a constant force, but we can calculate the average force using the impulse momentum theorem. And then we go to impulse and momentum. So J equals delta P, that's impulse equals change in momentum. And then I chose to write that underneath in one of the ways that we saw on the previous video that hopefully you put on your card. Impulse is F times T, force times time. And momentum is the final momentum minus the initial momentum. And then I went ahead and factored out the mass rather than write it down twice there. And then I substituted things that I knew. So I put the time in for T. I put the 0.15 kilograms in for mass. And the final and initial speeds I wrote in. So 40 is positive minus the initial, which was negative. So this is minus a negative 20. And the next line, I went ahead and did that. Minus a negative is the same thing as adding. So 40 plus 20 is 60. And 0.15 times 60 is 9. And we still got the F and the time over here. And then the last step, I just divided both sides by the time and got 15,000 newtons, which is quite a lot of force, but it is baseball bat and it probably hits that ball pretty hard. So I don't think that's unreasonable for an answer. So the steps are really kind of 5-fold. Sketch before and after, establish your coordinate system, define the symbols and list what you know, identify what you want to know, your unknown, and then solve using the impulse momentum theorem. Let's do one more example. So when I check your notes, I'm going to be looking for both of these examples in your notes, so make sure to write them both down. You may need to pause it or back up, or that's fine. So very similar situation. In this case, we have a rubber ball hitting a wall. So let's let that rubber ball have a mass of 100 grams. It moves leftward at 11 meters per second, strikes a wall, and bounces off to the right. If that wall exerts an average force of 400 newtons for 5 milliseconds, that's 5 milliseconds, 5 thousandths of a second, which the ball is in contact with the wall and bounces off, what's the final velocity of the ball? What's the final velocity? So again, notice that we have two things in the problem that are non-standard units. So one is grams, and so I'll remind you how we did that one way to convert, another way to convert. The power on the prefix here is 0 because there's no prefix. Kilograms is what we want, that power is 3, and it's always this minus that. So 0 minus 3, which gives us -3. So this is 100 times 10 to the minus 3 kilograms, or rewriting it another way, 0.1000 kilograms. Same thing with the 5 milliseconds to seconds. Milli is 10 to the minus 3. This has no prefix, so 10 to the 0. So this is -3 minus 0, which is -3. And so 5 times 10 to the minus 3 seconds, or 0.005 seconds. That's a nice review. And then we'll go into our method. So again, those 5 steps. First step is to sketch before and after. So I've done that over here in blue. Here's the wall and the ball moving to the left. And the after is the wall and the ball moving to the right. Establish coordinate system. Again, I let positive x be to the right, negative to the left. Define symbols and list known. So I've listed the initial velocity to be -11 because it's moving left. The mass, of course, is the 0.1 kilograms. The average force we're given, 400 newtons, and it's to the right. Remember, the wall can only push to the right, so that force is going to be to the right. So I labeled that as positive. And the time is also given. Identify the desired unknown. What we want to know is the final velocity. And then we need to solve. So again, impulse equals to change in momentum. Force times time is impulse. Change in momentum is mass times the change in velocity, because the mass isn't changing for the ball, just the velocity. And then we substitute. So 400 times 0.005 equals 0.1 times VF minus a -11 over there on the right. So step by step, 400 times 0.005 is 2. And then 0.1 times the quantity VF. Now minus a -11 is the same thing as adding 11. So I just did that there. And then I went ahead on the next line, I said 2. I dropped the units because it was going to get too busy, but they're still there. I went ahead and multiplied 0.1 times VF, that's 0.1 times VF, and then I did 0.1 times 11. 0.1 times 11. And 0.1 times 11 is 1.1. And I still have 0.1 times VF, and that still equals 2. So now I'm down to this line right here, and I need to solve for VF. So the first thing I did after that was I subtracted 1.1 from both sides. Got 0.9 equals 0.1 VF. And then in the end, I divided both sides by 0.1 to cancel the 0.1 multiplied by the VF. And so I get, in the final analysis, the final velocity is positive 9 meters per second. And it should be positive, it's to the right. And so that makes sense. All right, if you have questions tomorrow, make sure to ask in class.